So what I want to focus on next is a little bit more detail in terms of when we have this variable odds, what is the value of this variable? Okay. And so to help us with that, so really the focus here for the first part of live coding today is all about array references. So we've been revisiting this concept of a reference pretty much every unit throughout this whole year, because it's one of our more challenging concepts. And here's another similarity with variables that are of class types, as well as variables that are of array types. The value of the array variable is a reference to the array. Okay. So I've also tried to model this with our physical model on the board up front for us. So you can see I created a new array of 5 elements, and that's denoted by that little set there with 5 pockets, and that's initialized to our odd values of 1, 3, should be 5, 7, 9. Let me fix that. So these values, these 5 values, are not stored in the variable. They're stored somewhere in the computer's memory, right? Because all we can really fit in that variable is like a Wii remote, right? What if we had a million different numbers? That wouldn't fit in that pocket. We need to use some other place in the computer's memory. So this variable odds, the value of that variable is a reference. It's represented by that Wii remote that is referring to this array in the computer's memory of those 5 values. So let's be clear about that, because this both sometimes leads to confusion, but is also at the heart of why we can pass arrays as parameters and return references to arrays as return values, and why all of that works in Java. So variables of type array, like objects, contain a reference to the array stored in the computer's memory. Very similar to objects. And very similar to objects, assigning one array variable's value to another copies the reference, not the array's elements. And the good news here is this behavior is entirely consistent with everything else we've done this year. It's just like when we have 2 variables referring to the same turtle. Okay. So let's make this more concrete. Let's declare another variable that refers to an array of integers, and I'll call it more odds, and I will assign it the value of odds. And if I map this line of code to the physical model on the front board, and I have another array labeled more odds, another variable labeled more odds, that array variable is represented by this pocket. And when I assign it the value of odds, we take the value of odds and we copy this value. We don't copy this array, we copy the Wii remote. So I get another Wii remote that refers to the same array. So now we have 2 variables, both referring to the single array. We didn't make a second array. We never said new array again. Okay. Hopefully this is familiar with the whole turtle thing, where we had multiple variables referring to the same turtle. So just to make sure, if I write a line of code like this, odd sub 2 equals 6, and then I do system.out.println more odd sub 2, when we say odd sub 2 equals 6, it says, okay, look at this variable odds, follow the reference to the array, find the element at index 2, that's the 5, assign it a value of 6, okay, put that value in there. And then when we say system.out.println more odds sub 2, it says find the variable more odds, follow its reference to the array, go to the element at index 2 and print that value. Hey, it's 6, right? Because we have 2 variables both referring to the same array. This is really no different than changing like the pen color of the turtle like we did in our very first unit. So when we print this, it will print 6. So I want to bring this up again just to make sure that because it is a challenging concept, I want to revisit it each unit. I want you to see it presented in different ways, whether we're dealing with references to objects or references to arrays, because it is really at the heart of how a lot of features in Java work. Any questions about references in the context of arrays? All right. I want to show you then a new looping structure. So when we were studying loops, some of you asked about for loops, but you asked about for loops like we have in Python. And I said, well, the for loops we're learning right now are not like the for loops in Python. But today we get to see for loops that are like the for loops in Python. And in Java, we call these enhanced for loops. Enhanced for loops. What an enhanced for loop does is it iterates over each element in the array. It is similar to the for value in ... structure in Python that you might know and love. But and like that Python structure, something I just want to be super clear about is the value of the loop variable is the value of each element in the array, not the index. Okay. So when we use a traditional for loop like we did last week, when we were working with arrays, like for int I equals 0, I is less than odds dot length or whatever. The value of that loop variable I, the index, is the index in the array. It goes 0, 1, 2, 3, 4, 5. When we use an enhanced for loop, the value of the loop variable is the actual value of the array. Okay, and here's what the syntax of that looks like. We still use the for keyword, and we still use parentheses. We still need a loop variable, but the loop variable is not an index. So the type of the loop variable has to match the type of the elements in the array. In this case, that's an int. I think the loop variable should be named in the singular form of the array. So if I have an array called odds, my loop variable should be odd. If I have an array called people, my loop variable should be person. If I have an array called turtles, my loop variable should be turtle. Then we use a colon. That's like the in part. And then we specify the name of the array variable. So this is the syntax for an enhanced for loop. When I read this, I read it much like I read Python code, though. I will read this as for each odd, and then I replace the colon with in. For each odd in odds is how I read this line of code, because it just makes a lot of sense that way in my head. But again, just to reiterate it, the value of this variable odd is not set to 0, 1, 2, 3, 4, 5. It's not an index. It is set to the value of the elements in the array odds. It is set to 1, 3, now 6 because we changed it, 7, and 9. What happens like behind the scenes? I'll add a little comment here. If we were to peek behind the scenes and see how the Java compiler makes all of this work, it's kind of like there's this hidden code that says odd, which is the loop variable, equals odd sub I. So this is like done behind the scenes. I is automatically updated. Okay. It's basically writing the for loop for us, and it's basically adding this extra line of code, or it's basically writing the for loop to deal with the indices. It's writing this little line of code to copy the value from the element into our local variable odd. And then we can just do something like system.out.println, and we can just print the value. Cool. these enhanced for loops are great. They're great because we don't have to write a traditional for loop and make sure we get our loop bounds correct. It is impossible to be off by 1 with an enhanced for loop because we're not managing the loop. It's also nice not to have to deal with the square brackets and the indices when we're trying to find the value of an element. Instead, we can just use the loop variable directly. So lots of advantages here of the enhanced for loop. However, it's not perfect. There are trade-offs. And so with this convenience comes certain types of limitations. And these limitations, the first limitation focuses around this hidden line of code right here where it says odd equals odd sub I, which if we think about it, there's got to be something like this that makes this whole thing work. Where does the local variable odd get its value from? But it does result in some limitations. So let's make sure we capture those so that if you're aware of the limitations, you can make smart decisions in terms of which type of loop you use. So limitations of enhanced for loops. The first one focuses around this local variable. So the local variable, in this case odd, contains a copy of the value of the element in the array. Okay. In terms of our physical model, when I create this new local variable odd, I get a little pocket that can fit an int. And then when that loop runs for the first time, it's going to take the value of the element at index 0, the 1, and it's going to copy it and store it in this variable odd. So odd is going to have a value of 1, okay? But it's copied it here. And so just to be super, super clear, what that means is if I change the value of odd, that changes the number written on this little slip of paper in this pocket, and that has no impact on this array, okay? That's the primary limitation of the enhanced for loop. We can't change the value of any of the elements. Let's add that here just so it's not implied, but it's super clear and explicit. We cannot change the value of the elements in the array. Because Java is automatically copying those values in that local variable, we have no direct access to the array. We cannot change any of its values. Very often, that's fine. We don't need to, okay? But I want to be clear, like that is a limitation. The second limitation is that all the indexing is hidden behind the scenes from us. So as this loop is iterating and as we have different values for odd, we cannot easily, at least, determine the index of an element. We know the value of odd, but we don't know if we're at index 1, 7, or 3000. We can't easily determine that index. So imagine we wrote a line of code, or we wrote a few lines of code like this. We used an enhanced for loop for int odd and odds. And then inside the body of that, we did odd plus equal 1. And then we print everything out for odd and odds again. System.out.println odd. So compile and run this and check and see what the value is. On this first iteration of this for loop, when we say for int odd and odds, again, we're going to copy the value from the array at index 0. We'll copy the 1 onto here. When we say odd plus equals 1, well, we definitely add 1 to odd and store that back in the variable. So odd will now have a value of 2. And sure enough, that's stored in that little pocket. But that has no impact on this array. And in our next iteration, behind the scenes, we go to the next element. It has a value of 3. we're going to copy that value and store it in the variable odd. And odd is now going to have a value of 3. It never mattered that we incremented odd from 1 to 2 because we never did anything with it. It's not remembered anywhere. It's not stored anywhere. That loop is just a complete waste of time. It doesn't do anything useful. And if I actually run it, oops, I forgot to comment out our purposeful array index out of bounds exception. All right, I'm going to comment that out so it doesn't throw an exception. There we go. We can see that it prints out all the values. We ran that loop, which didn't do anything useful in terms of incrementing the values in the array, and they're still the same values they were before. So here's the decision we should make. When you're writing code, if you need to change the value of elements in the array, you should use a traditional for loop and just be careful about your loop bounds. If you care about the indices, you should use a traditional for loop and use that loop variable as your index variable. If neither of those are true, use the enhanced for loop. So much easier, so much less likely to result in some sort of careless mistake. So that's the advice when it comes to the enhanced for loop.